Today's lesson is on modeling addition with integer chips. With integer chips, we're going to use little circles, little yellow circles and red circles. The yellow circles are going to represent +1, and the red chips are going to represent -1. The reason we need positive and negatives is because, remember, integers are the set of positive and negative whole numbers. All right, before we begin, let's think about what happens when we have a +1 and we want to add a -1. Remember from 2-1 that we called these two numbers, +1 and -1, they're called opposites because they have opposite signs and they're the same distance from 0. They just happen to be the +1's one space to the right of 0 and -1 is one space to the left of 0. The other vocabulary word for opposites is additive inverse. And the reason we call them additive inverse is because when you add them together, you get 0. Or when you add them together, they undo each other. They disappear to 0. All right, and this is what it looks like when you model it. I'm going to save some time and not shade them in because it takes forever for me on my stylus. But when I have 1 plus -1, and we use those parentheses there as kind of a force field to shield that negative sign from the plus sign. It's just a way to separate it, saying that that is adding a negative. But I'm going to use a yellow integer chip to represent the +1 and a red integer chip to represent the -1. Now you can think about these as soldiers. You've got the positive side and the negative side, and whenever they come together, they battle out, and I know this is kind of graphic, but it's like they kill each other. They go to 0. There's nothing left when you have a 1 and a -1. So that's called a 0 pair because 1 and -1 are additive inverses. When they add them together, you get 0. So I represent it by going ksh, 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 ksh. They battled and they died. So 1 plus -1 is 0. Now let's think about what would happen with 2 plus -2. Well, I would have 2 positive chips plus 2 negative chips. Well, for every positive chip that has a negative chip, those battle out to 0 because -1 plus 1 is 0. +1 plus -1 is 0. So 2 plus -2 is also 0 because there's no survivors. Let's take a peek at these 4 different types of addition problems. It'll help us discover some patterns to integer addition. The first problem we're going to focus on is 2 plus 4. You guys know how to answer that one already. You've learned this one since what, kindergarten or first grade? 2 plus 4 would be 6. But let's go ahead and confirm it by using our integer chips. I have +2, so I'm going to need 2 yellows, and I'm adding 4 more positives. So 4 more yellows. Since these are the same color and the same sign, they can be added all together. There's no battling out here. They're all friends. They're on the same side of the battle. I'm just going to count them up. So I have 1 positive, 2 positives, 3 positives, 4 positives, 5 positives, and 6 positives. Altogether, my answer would be +6, which is what we knew it was going to be in the beginning. All right, let's go down to this problem, -5 plus -4. It's kind of the same thing except that we have these pesky negative signs. When you think about it in terms of our integer chips, you're just going to use 5 negative chips or 5 red chips, and you're going to add to that 4 red chips. Both of these are the same color. They're the same sign. -5 and -4 have the same sign. They're on the same side of the battle. So you're just going to count them up just like we did before. There's no battling out. There's no positives and negatives that kill each other, go to zero, whatever you want to call it. So just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. My answer is 9, but it's not just 9. It's 9 negatives. So I'm going to call the answer negative 9. Negative 5 plus negative 4 is negative 9. All right, let's move over to the right-hand side and examine what happens when we have different signs. So 7 plus negative 3, I'm going to start by drawing out my 7 positives. So 1, 2, 3, 4, 5, 6, 7 yellow chips to represent 7 positives, and 3 red chips to represent my negatives. Now remember, for every positive chip that there's a negative chip, those two battle out and go to 0 because positive 1 plus negative 1 is 0. I can keep doing that until one of my sides runs out of soldiers. All right, so I keep going. And now notice I crossed off 3 positives to my 3 negatives, and I don't have any more negatives to cross off, so I'm done, and I just need to count up what's left. So I have 1, 2, 3, 4 soldiers that lived. 4 soldiers, and those soldiers are positives. They're yellow. So my answer to 7 plus negative 3 is 4. Let's look down at the bottom, negative 5 plus 1. So I have negative 5 soldiers. That would be 5 red chips, and I only have 1 positive soldier. So just look at this problem. When you battle out, which side is going to win? Which side's going to have the survivors? Is it going to be the positive or the negative? Well, let's go ahead and battle them out. I have 1 positive soldier to 1 negative soldier. And I don't have any more to battle out because all my positives are gone. They've gone to 0. All my 0 pairs are gone. So I'm left over with 4 soldiers. But it's not just enough to say 4 soldiers. You have to recognize that they're on the negative side. So I'm going to write my negative sign. Negative 5 plus 1 is negative 4. If you look at our 2 columns of problems, you'll notice that the 2 problems on the left-hand side, both of them had the same signs. So in 2 plus 4, we were adding 2 positive signs together, or positive numbers together. And in negative 5 plus negative 4, we were adding 2 negative integers together. What happened when we were adding the same sign? What could we do? If you thought that, hey, they're the same, we can just count them up because there's no 0 pairs or no opposites to battle out and go to 0, we can just count them up or add them up. In other words, when you have integers that you're adding and they both have the same sign, all you're going to do is add the numbers together and keep the common sign. So same signs, add and keep. That's the first phrase of our lyric that we're going to learn for adding integers. If we look at the problems on the right-hand side of our boxes, we notice that in 7 plus negative 3, we were adding integers that had different signs. In other words, we had some positive chips and some negative chips. And when we did that, we lost some soldiers. Some of the positives were able to battle out with some of the negatives, and we ended up with less chips on the board than we began with. To represent ending up with less soldiers or less chips on the board than we begin with, we use the operation of subtraction. When we have different signs in our integer addition problem, so we're adding a positive and a negative, or a negative and a positive, so when we're adding different signs, we're going to subtract those numbers, and we're going to keep the sign of the higher number, then you'll be exact. And what I mean by the higher number is look at the side that has the more soldiers. So if we examine 7 plus negative 3, well, that positive side has more soldiers. In other words, if we go back to absolute value, the absolute value of 7 is 7, and the absolute value of -3 is 3. Those 7 and 3 represent the number of soldiers you have on either side. Since the absolute value of positive 7 is greater than the absolute value of -3, your answer is going to be positive. If you look down at -5 plus -1, you'll notice that the absolute value of 5 is just a 5, and the absolute value of 1 is 1. So a -5 plus 1, our answer is going to end up being negative because we have more soldiers on the negative side, so we'll have some survivors. To review, we'll have the lyrics of our song, To Row, Row, Row Your Boat. And the song goes, same signs, add and keep, different signs, subtract, and keep the sign of the higher number, then you'll be exact. Now, I'm going to sing it for you. No judgment. I'm not a choir teacher. It goes, same signs, add and keep, different signs, subtract, and keep the sign of the higher number, then you'll be exact. So again, same signs, add and keep, different signs, subtract, and keep the sign of the higher number, then you'll be exact. And that's it.